I'm going to show you Dr. Alsberg's work. So Dr. Alsberg also works in cell and tissue engineering, and he does different types of organs than some of us, for instance. But he's a full professor here, and as you can see, his core appointment is in biomedical engineering, but he is also has affiliate appointments in pharmacology, orthopedics, etc. And so his lab does it does tissue engineering. It tries to figure out, similar to what Dr. Shin described, it tries to figure out what are the microenvironmental and cellular cues, as well as ECM, that allow a tissue to properly function outside of the body in a three-dimensional space, so that when it's implanted in the body, it has a good chance of integrating with the host and fixing whatever ailment that is being targeted, whether it's fibrosis or cartilage defects or tracheal defects, etc. So Dr. Alsberg is world-renowned in what he does. He's showing in this slide deck, he's showing a few studies where it has come out in some very high-impact journals. This study, for instance, they're using essentially a microarray of various factors, biochemical and physical factors, to try to figure out how stem cells convert to cartilage cells. And this is a very high throughput technology that they have developed. In another study, they're actually generating tracheal replacements. So for people whose trachea might be fibrosed or it might be defective, they've come up with a strategy of using mesenchymal stromal cells and microspheres with various growth factors to start assembling these structures in these various tube-like formats, and then implant them in mice, and then really see how they're integrating into the host tissue. So here you have an example of sort of basically this is like a mini trachea, and they're able to do this. And this is something that Dr. Alsberg has had a lot of funding in. So if you're interested in tracheal replacement as a potential therapy, especially using stem cells, this is something that you can participate in his lab. Dr. Alsberg has also recently pioneered some very unique 3D printing technologies. So typically when people are 3D printing tissues, they might be using some sort of an ECM ink or synthetic ink, and that has its pros and cons. Sometimes those inks interfere with cells communicating with each other. Sometimes those inks are expensive. Sometimes they might be immunogenic in the body. So Dr. Alsberg has developed a ink-free printing methodology, where what they're doing is they're using essentially a bath of alginate based microgels. That is essentially, this bath can self-heal. So what you can do is you can print cells directly in this bath. The bath essentially will wrap around the cells and keep the cells in place until the cells essentially fuse into a structure that you would want once you've printed that. And then this bath can be dissolved away. So it's basically a way to print a ink-free cellular condensate that allows the cells to interact and form a tissue, and then the bath can be dissolved away. So it's a very unique technology. It's very high impact, and he's applying it to several different tissues, including cartilage and liver as well. Those are some of the organs, among others, that he's doing. The more recent work that he has put out is really looking at multi-hydrogel systems that can be reversibly morphed into three-dimensional shapes as a function of time. So here you see sort of multi-compartment or multi-composition hydrogels, where depending on how much time elapses or what stimuli you can give, it can morph into different shapes, and it can revert back to the original shape. Here you're showing that, so that this really allows you to control the architecture of the final three-dimensional tissue by really arranging it and having time-dependent actuation, where you may want the tissue in a specific shape when you implant it. Maybe you want it to flatten out afterwards. And this is something that's really extremely cutting edge. Very few people do this kind of actuation with hydrogels, and this is something that he published in the Science Advances, which is a very high impact journal. So if you're interested in this work, please get in touch with Dr. Alsberg. Like I said, he's a world-renowned leader in this space, and certainly you can't go wrong working in his lab. So